Welcome back, Chemistry 30. This is the shifts in equilibrium lab, and it looks like this. Just quickly going over what you need to do. You need to complete the purpose. You need to have a prediction for each one of these questions 1 to 4. You can just simply write it after each question mark here. And you need to answer the background question, state Le Chatelier's principle, and state how it applies to two situations if something is being added or something is being removed. So just kind of comment on that, and you might be able to squeeze that in just simply right here. Procedure, you don't have to do anything there. We'll just follow the lab handout, so you don't have to answer anything there. And you don't have to answer anything here because we'll do it on the last sheet here. You can also cross out this number 1 and 2. We're not going to do those. In the conclusion, yes, we will answer these 3 questions. What were you going to do? You can simply say the purpose was to da-da-da. What did you think would happen? It was thought that da-da-da-da would happen. So just basically summarize in 1 or 2 sentences what you expected to have happened over here, and then kind of comment, were you correct? What did actually happen, etc. Okay? So the actual lab is here, shifts in equilibrium. So observing and inferring Le Chatelier's principle states if the stress is placed on a system at equilibrium, the system adjusts in a way to relieve the stress. In this experiment, you will witness an equilibrium shift in a colorful way. So that's kind of what the purpose is there. The materials, test tubes, 10 milliliter grad cylinder, 250 ml beaker, concentrated HCl, 0.1 molar cobalt chloride solution, ice bath, table salt, and hot plate. Goggles, yes. Aprons, you don't necessarily have to. Gloves, you likely should, because we are using concentrated hydrochloric acid. So here is the procedure here, and it's all based upon the idea of this equilibrium right here. Okay? So cobalt chloride here, there's a certain side of the equation that's pink, certain side that's blue. Cobalt chloride is kind of like a pinky red, kind of a cranberry type color, but you can see certain things happen here. So for example, number 1, adding 2 mils of cobalt chloride to a test tube, record the color. So what is the color? Add 3 mils of concentrated hydrochloric acid, record the color that solution turns into. And yes, be careful, HCl can burn skin and clothing. So if we add HCl, HCl is actually adding chloride ions. So if I'm increasing this, which way will the equilibrium shift? Towards blue or pink? So you'll just simply answer the question. Now when you're doing the original hypothesis, you're answering these questions. When I add HCl, what do you think the color will be? So adding Cl ions to this solution will cause an imbalance. Which way will the equilibrium shift to be in balance again? So use this equation to predict what in fact will happen on your hypothesis page, and then here when you actually do the lab you answer these parts. To avoid transferring HCl, there's a little rule here. 3 mils of hydrochloric acid is 60 drops. So you'll see dropper bottles of concentrated hydrochloric acid. Use this. Don't try to pour it into a grad cylinder and measure out 3 mils, because you're more prone to have it spill on your finger. So 60 drops is our 3 mils. Then add enough water to make the color change. To make a color change occur, record that color. And now if I were you, I'd add a little bit of water, put a stopper on the test tube, shake, add a little bit more, etc., and then write down what happens. And you'll notice that, oh, water is in this equation too. If we increase water, which way shall it shift? And then that's done. At the end of number 3, that's done. Just dump it into the acid dump beaker that you'll see. Then rinse it out, and then get a new, because we don't want to dump hydrochloric acid directly in the sink. So put it in the acid dump beaker and it will be neutralized. Then after you've rinsed out the test tube, again put 2 mils of cobalt chloride into a test tube. Add concentrated HCl dropwise until the solution is a purplish color. If the solution becomes blue, add water to turn it purple. So add just a little bit of a time. Again, use a stopper, shake it to get a purplish color. And then we'll place it in an ice bath. Just because what's going to happen there is the ice takes away heat. And then after that we'll put in a hot water bath in which heat is added to it. So in one we're taking away heat, the other one we're adding heat. Okay? So back in the hypothesis section here, so adding HCl, what happens? Adding H2O, what happens? Yes. And then when you have your purplish colors, your reaction's either going to be endothermic or exothermic, and that's the point of using an ice bath or water bath. So if you take a look here, if it is endothermic, that means we can think of heat as being on the left-hand side. So if we're increasing heat, which way will it shift to alleviate that stress? Or if we put it in an ice water bath, if we're taking away heat, taking it away, which way will this shift to get into equilibrium again? And then number 4 here, if it was exothermic, what would happen if heat is added or heat is taken away? So you imagine that heat is on the right-hand side. If we add more heat, which way will it shift to become in equilibrium again? Or if I take heat out, which way will it shift to be in equilibrium again? So those are the things you're going to have to predict. And then when you finally get your answer here, you'll be able to determine, well, is it endo or exo? Okay. The analysis questions, use the equations to explain your observations in step 1 to 3. So the step involving adding HCl and the step of adding water, you could simply use this down here. I'd copy out this and use this as reasoning here. So the first stress was increasing Cl, the second stress was increasing water. Of course, you know what the color is going to be, or you got the color, so which way what was the response, and then what way must it have shifted in order for that to happen? So just fill this in. And then lastly, explain how the equilibrium shifts when energy is added or removed. So on the flip side of this page, folks, you can do the same thing. Well, when I added heat, it turned this color. When I took away heat, it turned this color. Because of that, this means the response must have been this, and it shifted in this direction, response and shift. Because of the colored things that happened here, you'll be able to look back here and determine, well, does it match up with my endothermic predictions, or does it match up with the exothermic predictions? And then the last sentence here will be using this above data and the hypothesis predictions. It must be either endothermic or exothermic, so make sure you answer that. Okay, so that is the lab there, and the start items are what you need to complete: purpose, hypothesis, background, and the conclusion, and of course filling in these underlines here as you're doing the experiment and answering these questions number 1 and number 2. Okay, we'll see you again.